Okay, so this is our 3.1 formative quiz on squares and square roots. So as we go through these, follow along. We'll make these worth various points. First four are true and false. They're always worth 2 points each, 1 point for the answer, 1 point for the explanation. Question number 1 says 3 squared is equal to 6. Is this true or false? The answer is it's false. Why is it false? Well, there's various ways you could do it. You could say 3 squared is actually equal to 9. That's probably the most popular answer. 1 point for false, 1 point for that answer. You could also say, what is the square root of 6? Square root of 6. You could technically say, so well, that's not right. Hang on. Square root of 6 is 2.449. So you could say technically 2.449 squared is approximately equal to 6. But I'm sure no one did that, so we won't worry about it. Question number 2 says the square root of 100 is 50. That's also false. The square root of 100 is actually equal to 10. Or, if you were really sophisticated, the square root of 2,500 is equal to 50. Both of those answers is probably on somebody's paper. Did anyone say the square root of 2,500 is 50? Anyone go that way? You did? Outside the box thinking. I like it. Question 3 says 8 is a perfect square because 4 plus 4 is 8. The answer is false. A perfect square is not the sum of two numbers. It's the multiplication, the product of two numbers. So false. And I would say you can't add. You can't add numbers. You must multiply the same number. Or a better way to say it is, perfect squares are created from the product of two numbers, not the sum. That would be the better one. Either way, false with any kind of answer to prove it would be fine. And finally, number 4 says 100 has 4 prime factors. Let me just press pause in my recording. Okay, so back to this. It says 100 has 4 prime factors. So if you prime factorize 100, how many of you went 2 and 50? A lot of you. I'm going to go 10 and 10, neither of which is prime, but I know that 10 times 10 is 100. Right off the bat, I know that 100 is a perfect square because I have two numbers that multiply together that are the same, but neither are prime. 2 times 5, those are both prime. 2 times 5, those are both prime. So the prime factorization of 100 is 2 times 5 times 2 times 5. Those are the products of prime numbers that give you 100, so therefore the answer is true. It does have 4 prime factors, and that would be the proof that I would use. Question 5, 6, 7, 8, 9, etc. are all just short answer questions. It says, what's the area of a square whose side length is 20 meters? So if you drew this, and you put your little lines here to show that that's a square, put 20 meters here. The area of this square, the formula for area of a square is side squared. So 20 squared. So 400 square meters is the area, right? The best way to show it would be, of course, utilizing your formula, squaring 20 and showing that it's 400. Question 6 says, what's the side length of a square whose area is 64? So now we're reversing it. And when we reverse it like that, we're going to say, so right now we have the area is 64 meters. Oh, it should be meters squared, shouldn't it? Oops. So if we say the area, which is 64 meters, is equal to the side squared, right? If I write my formula, area equals side squared, but instead of area, I actually write the area of 64. Using the idea of maintaining equality within an algebraic equation, what can I do to both sides to get it down to not side squared, but rather side? What can I do to both sides here? Anybody? Yeah. Find the square root of both sides. If I square root this side and square root this side, remember what we talked about with algebra. Whatever you do to one side, if you do the same thing to the other side, you will maintain equality. The square root of 64 we know as being 8. And what number multiplied by itself is side squared? It's side, so just s. So therefore, if we use work there, we could say 64 is equal to side squared, or 8 equals s. Now, probably most people just did this. And if you did that, that's okay. But I want you to really kind of internalize using algebra to solve that, right? The area of a square is equal to side squared, so area is equal to 64, etc., etc. Question 7 says prime factorize 256 to prove that it's a perfect square. Most of you probably did 2 and 128. Circle that. 2 and 64. Circle that. And then as we go down here, what we will have is 64. Now some of you might have went 2 and 32. I'm going to go 8 and 8. Do the smart thing. Neither one are prime. 2 and 4, prime, not prime. 2 and 2 are both prime numbers. So we'll do this one more time with 8. 2 is prime, 4 is not. Branch that down, 2 and 2. So when we break down 256 into the prime factors, if I took a calculator, and I'll grab one right now, and I was to multiply all of those circled prime factors, 2 times 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 2, and press equals, I would get 256. So therefore, there are 1, 2, 3, 4, 5, 6, 7, 8 prime factors. All of them are 2s. So if I was to redistribute them into 2 groups of 4, both of those groups would be equal, and both of those groups would be equal to 16. And therefore, 256 is a perfect square because 16 times 16 is 256. Question number 8 says a square field has an area of 6,400 square meters. How far would you walk around it if you went around it twice? So if I drew my square here and said the area is 6,400 meters squared, and the area of that square is side squared, or 6,400 is equal to side squared, what would I do to both sides to figure out the side length? I'd square root 6,400, wouldn't I? So if I grab my calculator and say, what is the square root of 6,400? It says 80, which means that the side length of this field, or this square field, is 80 meters. Now, how far would you walk if you went around the outside twice, or the perimeter twice? What's one lap going to be? 320. What's 2 laps going to be? Double 320, it's going to be 640 meters is the distance I would walk. That's the answer. Now, let me show you how I would have done that. What is the perimeter of a circle? What's the formula for the perimeter of a circle? Or a square, sorry, not circle. Not side squared, that's the area. Side plus side plus side plus side, or, since repeated addition is the same thing as multiplication, side times 4, or, which say 4 multiplied by the side length. So the perimeter of this one would be 4 times 80, correct, which is 320. How many of those do I need to do if I walk around it twice? 2 of them. So I take one perimeter and multiply it by 2. Or technically, the perimeter walking around it twice would be 8 multiplied by the side length, over 8 times 80, which is 640 still. So either way, 1 point for work and 1 point for the correct answer of 640 meters. And finally, question number 9 in this side. It said, is 200 a perfect square? How many prime factors use prime factorization to determine? So 200 we're going to write down here. I'm going to go 2 times 100, and then we're going to go 10 times 10. And before I go any further with my prime factorization, can I tell right now if 200 is a perfect square? Right now I can tell, because there is no way I'm going to be able to make 2 times 10 times 10 into 2 equal groups of products. So right now I can say, no, it's not a perfect square. But keep going. 2 and 5. 2 and 5. So now that I have it broken down into its prime factors, how many prime factors does it have? The answer is it has 5 prime factors. Is 200 a perfect square? No, it's not. And there's the work for it. So 1 point for no, 1 point for 5 perfect squares, or prime factors, and 1 point for the prime factorization tree. So question 9 is really worth 3 points. How many prime factors does 10 have? 10 is real simple. 10 breaks down into 2 and 5. How many prime factors does it have? Just 2. Question number 10, 2 prime factors. We'll make that worth just 1 point. Why don't we just balance it out and make it worth 1 point? Scroll on down. Scroll on down. Erase this up. Our next question, what number is this again? It's hidden behind my thing. 11. So 3 squared is 9, a standard form, 1 point flat. 5 squared is 25. 12 squared is 144. 100 squared, do 1 times 1, which is 1, and then double your zeros, which is 4 zeros. You get 10,000. If standard form is 64, exponential form, in grade 8 right now, we're only going to say 8 squared, but technically, 64 could be 2 to the exponent of 2, 4, 8, 16, 32, 64, 6. You could write that as well, right? Because 2 to the exponent of 6 would be this. But since we don't know that yet, I don't think anyone had that. I think everybody had 8 to the exponent of 2. And finally, 400 would be 20 to the exponent of 2 as well. So 1 point for each of those, that's 6 points. 1 point for each of those, which is 6 points. And then scroll down, and our last question. You're given the square root of 25. Standard form would be 5. Square root of 1 is 1. Square root of 144 is 12. The square root of a million, what times itself? If we take a calculator, what do you think it is? Is there a number that's the square root of a million? What is it? How many? 1,000. Oh, shoot. If I take a million and square root it, I get 1,000. But if I also think of it as 2 groups of 3 zeros, I know that it's going to be 1,000 as well. And finally, what the square root of what is 19? The square root of 361 is 19. That's worth 5 points.